Okay, hello everyone and welcome to the second episode of the CRPL programming tutorial. In this episode we will be taking a closer look on what to type into the script itself. I mean, not like this. Yes, here, edit. What I need to type here in order to make it work. So if you are wondering what these commands do, this video will answer it. So first let's create a new script, just test. We will name it just test.prpl and let's click the edit button. Now the first thing you need to know about how the actual code inside the script works is that the code itself is composed of commands. So all of these are commands. So this is one command, another command, another command, another command, and so on. Just one command after the other, and each command does something slightly bit different. The most simple command is just a constant, like this. So right now I have 3 commands and each of them will put a single value on the stack. So this command 1 will put the value 1 on top of the stack. This command 5 will put the value 5 on top of the stack, and so on. So the quite important thing to know is what is the stack. So let me open this awesome program that I will use to explain, and let's move it to this to the right and this to the left, so I can illustrate. So the best way to view the stack is maybe like this. That's how I like to draw it. And this is an empty stack. It has a bottom here, and it has a top over here. Now, if a command like 1 is executed, all this will do is it will put 1 on top of the stack. So you can imagine the value 1 like falling into the stack like this. So after the command 1 is executed, so I will put maybe 1 here to signify that the command 1 is executed, and it will end up with the number 1 here at the bottom of the stack. Now after 5 is executed, the same thing will happen, right? Imagine 5. So the stack looks like this, and then the 5 will be put on top of the stack. So it will, like, you can imagine it falling down the stack and landing on the 1 here. So there will be 1 and top of it will be 5, like so. Again, here is the bottom of the stack, here is the top, and finally 6. You can see what will happen. It will be just 1, oh my bad, 1, 5, 6. Yeah, I can put the command 6 here to signify this transition. And this is how the stack will look after these 3 commands are executed. Now let's do something more interesting. Let's try the add command. Now, as the name suggests, this will add numbers together, and what this will do is it will take the two numbers from top of the stack. So again, you can imagine that the command add would suck the two topmost numbers. So it will just take the 6 out, it will take the 5. You can imagine like a hand reaching into the stack and taking the 6 out, taking the 5 out. So it takes 2 values from the stack, then it then adds them together, and then it puts the result back. So it puts, of course, the result 11 back on top of the stack, because 6 plus 5 is 11. And then what we can do is we can just print the state of the stack, which I believe is done with trace stack. This command will just read the content of the stack without changing it, and it will print it into this trace log. So again, we need to enable the trace log so that we can see what is going on. So let's do that. Compile all. We see 2 scripts successfully compiled. So let's create a new core somewhere over here, doesn't really matter. And then, yes, I need to edit map, add the script to it. Yes, click the arc button, close, and then you should see after I unpause the game, yes, you can see that 1 is at the bottom of the stack and 11 is on top. So that's the basic. Again, every command just either adds numbers on the stack, takes them out, or does both. For example, add takes 2 numbers, adds them together, and puts the result back. And some commands like, for example, set length, is a very simple example. So let me go into, where is it, CRPL. Yes, CRPL reference, let's close this. And let's try to find, yes, setland. So this is a simple command that you will also learn this, that this is called the notation, and it will tell you how many arguments does the command take and how many does it return, and the difference between them is this dash here. So this tells you that it takes 3 integers. Now this means 3 whole numbers, and it doesn't return anything. So this command setLength will expect that the x coordinate, or this will of course set the height of the length at some position. So the x coordinate, it expects. Okay, let me show you with an example. I think that will be most effective. Let's say I want to set the length over here to be the highest possible length. Now what is the highest possible length? I don't know, to be honest. It seems that 10 is the highest possible length. Now, I can actually hover over this to see the grid, so that's pretty nice. But that doesn't matter really much. I mean, doesn't matter where exactly it will be, just to show you. So this, I think this point here is coordinate 0, 0. So if I want to set over here, somewhere the x coordinate, let's try 10, and y coordinate, let's try like 3. I mean, you probably have no idea what's going on, but don't be afraid. It will be clear soon enough. So 10, 3, these are the coordinates, and then I need to set the length height. So it's 10 again. So that might be a bit confusing, but yeah. And then I just call the setLength command. So as previously, this will just put. Okay, let's do at the position 8, 3. So the position is different from the length height, just to be more clear. So again, this will put 8 on the stack, then 3, then 10, and then the setLength command will take these values from the stack, and it will process them by actually setting length to height 10 at these 2 coordinates. So let's see that it actually works. So I go again into scripts and compile. And something is wrong. Invalid token setLength. And that's because I'm on the wiki for CRPL, my bad. Okay, let's try to fix that by going here. Yeah, this is the correct wiki. Oh no, I mean, I already have it as bookmark, so let's just close it. I misclicked. Okay, setLength. Okay, what is the command to? Oh, I think it's set terrain actually. Yeah, get terrain, set terrain. So my bad, yeah, the command is exactly the same, but it's set terrain instead of set length. So I apologize. So just set terrain instead of set length, everything is the same. You can even see, yeah, that it's just the XY coordinates and then the level. So let's see if it actually works. Compile all, close, and bam. You can see that this land here got set to the level 10. If you see here on the bottom, you can see level 10. So that's pretty neat. Yeah, you can even get terrain, of course, which is very similar, but it only takes 2 arguments and then returns 1. So that's why the notation looks like this. It takes the coordinates and returns the number. Now let's try to have a little bit more fun with it. And instead of just putting these numbers there like so, let's compute them with some computation instead. So for the x coordinate, I will do 4 times 8, which is 4, 8 multiplied. Again, the way it works like this, let me show you here. So can I just delete everything? Yes. So first we start with empty stack, and then we put a 4 on it. Then we put an 8 on top, and then we multiply. Again, multiply will take both of these numbers out and multiply it and put the result back in, which is how much is 4 times 8? I don't know, 32, right? So after this multiply is executed, only the number 32 is on the stack. So next, for the y coordinate, let's do, I don't know, 50 minus 20. For example, so after that, the number 50 is put on top of the stack, then the number 20 is put on the stack, and then the command sub, which means like minus, but differently set. I don't know what is this, what the shortcut is for, but this is minus. Subtract, yeah. Again, it will do 50 minus 20. Now you can see something interesting, that the second argument for the subtract function is actually on the top of the stack when the command subtract is being executed. So it actually does 50 minus 20. Even you can imagine that the subtract function, again, like a hand reaching into the stack and taking the 20. So even it takes the 20 first, it will actually subtract the 20 from the 50. So it's 50 minus 20, which is 30. So again, let's do with my horrible drawing, 32, and then 30, which is again 50 minus 20. And then for the height, let's just do 8. Or I can even do 8, 6 maximum, and you can again imagine easily what will happen, right? 8, 6, and then maximum from 8 and 6 is 8. So the maximum function, you can again imagine it reaching into the stack, taking these values out, computing the maximum, and then putting the result in, which is 8. And on top of that, we just call set terrain, which takes all these values out and set at x position this, y position this, and this is the total height. And these are maybe too similar. So let me change this to 50 minus, I don't know, 40. Or let's just leave it like this. It will be fine. So let's try again. Compile all, close, and where is it? Is it under this? Yeah, I think it changed the length under the command module. So let's see, and here it is. And it is the length height 8. So that is the basic of it. Now with this in mind, we can go back to this and see every command used here, and I will explain exactly how it works. So first we start with these debug commands. Now let me just show you what happens if I don't clear the trace log. It will be fun. Oh, I don't actually trace everything. So instead of set terrain, I use the trace tree command. What this will do is it takes the 3 topmost attributes from the stack and it prints them into the trace log. So let's see this. Let's see. Compile all, close, and you can see that it prints these 3 numbers like 32, 38, like crazy. That's because the script actually gets executed 30 times a second on each frame. So that's why it is printing the text like crazy, and if I clear the trace before each print, it will only show 1 message at a time. So that's why the clear is there, right? And if I do hide trace lock, it completely hides the lock altogether. So even if I do the trace command, it will not show. So of course if you finalize the map, I think it doesn't even show, but I'm not sure. But anyway, you don't want like a million messages if you know that your program works. This trace is only useful when we are making your script. Maybe it doesn't work and you want to know why, so you just print some variables or something else to see if your script is working or not. So that's the start here. I will get to this later. So what is the set unit attribute? Well, units in Creeper world have different attributes. if you click on the, click here and then click here again, you can see all the, how do you call it? All the attributes and the description. So you can change the position with it. You can change the height and width. This is not the height and width of the image, that's set differently. This is the how much space does it take on the map. But since we don't want to take any space on the map, there is a thing for that as well. Take map space. Yeah, consume space on the map. And you can see that this is set to 0. So what I did is I set that it doesn't count for victory. Again, you can see the, yeah, here. Yeah, must be destroyed. So I don't want to require the player to destroy this unit. Oh, sorry, my bad. Because this script will be an undestroyable script. So it wouldn't make sense for the player to need to destroy it, because otherwise he couldn't win the game. So next we have yeah, create buffer zone. Now this doesn't matter much because the script cannot be destroyed, but I set it to 0. This is whether or not it destroys the buffer zone after it's, I mean case buffer zone after it's destroyed. Again, you can see it here. Just more on this command itself. Again, you can go into here and see that it takes 3 arguments. The ID of the unit. Now this is important. There is also a command self that will put the ID of the current core that is running the script on top of the stack. So again, you can imagine the stack being empty, and the command self will put the ID of the unit, which is just a number like 10 or something like that, on top of the stack. Then this command, this will actually put a number as well, because each of these attributes actually has a number that is like unique to that attribute. So I don't know what's the number for this. It will be like 20 or 13 or something like that, and it just puts the number on top of the stack. But the set unit attribute command will understand the number, and it will know that this number created by this command means the property counts for victory. So that's how it works. And it's important to know it so that you don't do this by accident, because by doing this you are actually putting the string. This is a command that just puts a string constant on top of it, and to be honest, I'm not sure if this command will know what to do with the string. So don't use it like this. Use it like this instead. This is a command that will put again a number identifying this attribute, so that this command will know what to do with it. And lastly, this is the value. So again, if I want if I want the player to have to destroy this unit in order to win, I would just put 1 here. But since I don't require the player to destroy this unit in order to win, I just put 0. Same with the other ones. I don't want this unit to take map space, so I just put in 0. And just so you see how it looks if a unit does take map space, so you see how I cannot build this collector over another collector. The same goes for the CRPL core. It does take map space by default, but not these cores that are here. See, because I set it with 0 like this. So that's for the set unit attribute. Now for images, I will do an entire episode on images later. So just briefly, again, you can just look up this yeah, this command here, and again it takes the ID of the unit. So this is again, you can use self, so you so this means that it is the same unit that is running this script. By the way, this is useful, this parameter here, because you can set images and attributes like this on different units than the script itself. So maybe you have one script that manages multiple units and it sets images and attributes for them as it wants, and it sets the image ID here. But since here we want to modify the same same CRPL core that is running the script, we just use the command cell. Now this is the image, like image name, or how is it called? Yeah, image slot. Now a core can have any number of image slots. I mean, the maximum is like 100 or 1000 maybe, or something like that. I'm not sure. But yeah, the unit has one image by default on the image slot main, and this is the image name that you override. I mean, this is I mean, it's not that complicated. Once you know how it works, you can even upload custom images here and then set them to course as well. But as I said, I will cover images in a completely separate episode. So this for now is just a way to quickly make the core invisible by setting the image to, I think none is like completely transparent image, if I'm sure, if I'm correct, or maybe it just doesn't render the image at all. Anyway, it is invisible. So that out of the way, let's get to the fun stuff. First, let's take a look at this code, get unit add. Again, we can just look it up. This is what you will be doing most of the time. You will be looking up how commands work. Now you can see that this takes two arguments, the coordinates, and returns the ID of the unit, which is again just a number. Now I save this into a variable, more on that later. But let's change it so it doesn't work. So right now the current x will put the. Okay, let me actually do this so you can see. Right, this will be fun as well. Right. So this will trace again. This will put the current x position of the script in. I mean of the core in which this script is running on stack. This same for the y. So then there are two numbers on the stack, and this will print both of them. So if you want to see that, how that looks. Oh yeah, of course, I need to show the trace log. Bam. So now if I edit the map and move it, for example here, you can see the different coordinates being printed, right? So I said the top left is 0, 0. So let's see if that's true. I will put it right here and unpause, and as you can see 0, 0. Now as I move it to the right, it increases the x coordinate, and as I move it down, it increases the y coordinate. So you can see that if this script is here, then the unit that would be here would have the same coordinates. So I can even do it like this. Oh, this is bad, almost not readable. Okay, so maybe let me move it like here so you can see a little better. Right, so the x this is the x position, so imagine that is the same, but the y position is one less on this script because it's more on top of the line. So if I want to, if the script is here, right under the emitter, and I want the position of the emitter, which is 1 above it, I just need to decrease the y coordinate by 1, and that will give me this position of the emitter. Now this will, oh, I just add there just so that it wouldn't work, but let's put sub there so it works. So again, let me use my awesome drawing skills. So first the x will put x there like this, then the y will put y there like this, and then the 1 will put 1 there like this, and then the sub command will take both of these out. Right, it will take 1 out, then it will take, if I can just, like, it will take the 1. Oh, this is a bad way. Like this, it will compute y minus 1, and it will put like the single number that is equal to y minus 1 on top. So I don't know what this will be, but if y is like 20, it will be 19. So this is already the number which is the result of the computation y minus 1. There's just a single number on the stack, like 20 and I don't know, 19. If y was 20, there would be just 19 on the stack. There wouldn't be like an expression of actually like y minus 1. No, there would just be one number on the stack. I'm just writing y minus 1 because I don't know what that number might be, just so you understand. And then again, there are just two numbers like this, and then the get unit at gets the position, and that and returns the ID of the unit which I save into a variable. Now I print the variable, so let me see what happens if I move it into a bed position like this. So oh yeah, I need to compile again. Okay, now this is a variable, and variables work like this. Okay, let me again delete everything. Let's say you have a number on stack which is 5, and you save it into a variable named emitter. What this will do is it will take the number from the stack, so the stack will be empty afterwards, but the value 5 will end in a variable named emitter. So you can see like a separate table of variables, and the variable emitter having the value 5, or whatever this function returns. Now if I read from the variable, the value will go back on top of the stack, but it will remain in the variable, so I can read from it again. So that's how variable works. Again, more on that later, but this is the basics. Now let's get to the perhaps more interesting thing, and that is get units in a range. Now again, you can just look it up here. Now what will this do? Now this is interesting, because first it takes the coordinates, and this is the center of the search. So this can this can search for units in a range. So maybe if I want to find units that are in this circle, I would get this coordinate, this range, and just put it into the function, and it would find the units for me. But since I want to find all units, I just put the center of the search, doesn't matter, can be at 0, 0, and the range something really large, like 1000, which is way more than the maximum map size. So this will find all the units for sure. And the result looks a little bit weird at first, but you can see that yes, this as you saw this hang on, this will be interesting. Yes, as you saw the commands like add, for example. So when you have 1, 2, 3, and then you do the add command, it just takes 2 numbers and it puts 1 number back, right? Well, get units in range isn't like that, because while it takes 3 numbers from the stack, oh, I don't want to undo this. I want to undo this. So let's extend the stack a little bit. So let's put these numbers here, 0, 0, 1000. Now, get units in a range will take these 3 numbers from the stack. Again, why is this focused, right? Take these 3 numbers from the stack, and it will find the units, and then it will put the ID of the units, it will start putting them on the stack. So let's say it finds 4 units, so it starts putting the IDs of the 4 units on stack. So let's say the IDs are 14, 20, 30, and 105. So these are the IDs of the units that it found, and then it puts the number of the units that it found on top. So you'll see how many units it found, and then you'll see the IDs of those units. Now what I do is I just save the number of the units into a variable named unit count. So again, there will be a variable named unit count with the value 4 that will also delete the value from the stack, this this save into variable operation. Again, you can imagine the saving into variable like a hand reaching into the stack and taking the for out of it, so the for will then not be on the stack, and putting it into the variable itself. However, if I read from a variable, this is a variable read, you can imagine a hand just copying the value for from the variable and putting it on the stack, but not destroying it from here. So I guess that makes a little sense, if at all. But again, I just print how many units were found, so just so I know. Okay, so we are going for the finale. Now let's do some arithmetic. Now you saw enough of work with the stack. I don't think I need to draw anymore. So first we take the number of units and multiply it by the coefficient. Now this works a little bit like writing into variable. So for example, let me comment this out. Again, hashtag will just make the rest of the line a comment and do 1.0 into coefficient. Now this script will work just as well as previously, except as you saw last episode. Now if I go into script compile all, I edit the map, even put this where it should be, and I cannot change the coefficient here. So I have to have the amount of creeper be exactly the amount of units. I cannot change it from the editor. So a way around that is to use it like this with the dollar sign and the semicolon, and just put the name of the variable here, and here put some predefined value, and it will serve as a input parameter that you can then change in the editor. And then in the script it's just more or less a normal variable, except it has a predefined value that's not set in the script like this. I mean, you can override it if you want. So now if I leave it like this, then you can set it in the editor, but the setting from the editor doesn't matter because you override it in the code as well. So this is useless right now because it gets overwritten anyway. But if I delete this, then this is very useful because the editor, the value of this variable will be set from the editor with this serving like as a default value, and then you can read it here. So after you get your number of units, you just multiply it by the coefficient. Now this, after this multiply on the stack is how much keeper you want to produce, but remember you have to multiply it by million. What is it set? I'll just copy paste this command. Right. It will tell you here that you need to multiply it by a million if you are setting amount of creeper via this method. So that's why you multiply it by a million and save it into another variable just to make it more easy to read. And then you use this as is advised here. So if you look at some of the... Oh yeah, I didn't get to this. Again, I will leave this for a later tutorial. But you just put the unit which you want to edit, the parameter that you want to edit, in which case is the production amount. Again, you can copy it from here. Then the value, and you put 0 here because yeah, you can. That is the way. This command was originally created so that you can change variables in another CRPL course, and here would go the name of the core, but since this is a default unit that doesn't have a core, that's why the 0 goes there. So that's the too long didn't read version of why is it called like this. So after this, I hope you know how to use the script. So I think I will make a little homework for you, just something easy that would make sure that you understand what is going on. And yeah, I know what I wanted to do. Instead of just having Oh, I think I need to recompile. Oh, what is this? Yeah, compile all, close. Okay, now edit. Oh yeah, I see coefficient. Oh, it even remembers it anyway. So let's move this around so just they are like they were before. So what I want you to do now is go into the script and change it so that when I open it, I not only can set the coefficient but also a base amount. And the way this would work is the amount of creeper produced will be base amount plus coefficient times units created. So for example, you can have a emitter that will always create at least 10 creeper, but with each unit it gets even more powerful. Or even better, you can have by setting the base amount to negative, you can have an emitter that starts creating anti-creepers, so it gives some cover to your base. But as you expand, it creates less and less creeper, and once you have a big base, it doesn't create anti-creeper anymore, it starts creating creeper instead. So that will be cool as well. And all with a single parameter like base amount and changing the formula from coefficient times units to base amount, or how did I call it? Yeah, base amount, for example, plus coefficient times unit. So pause the video now, make the changes, and unpause the video to see the solution. Okay, now let's see the solution. It is really simple. You just add another parameter here, base amount. Let's start at 0. Oh, this let's put 0.0 here. Let's why is this important? Well, let's actually show you why it is important. It's not that difficult to understand. There are different types of values. As you can see, there are numbers like 1, 2, 3. There are strings, and there are also floating numbers, which are like real numbers, like 1.5, for example. Now you cannot change the type of the how do you call it, of the input parameter. So for example, if this says float, I cannot put a string there. Like I'm sure this will like say no, it doesn't work. See, it just says nope, and it goes back to the default value. So that's why I put 1.0 here, so that I can put 1.5 if I want to. Because if I just put 1 there, like without the 0.0, let's just see what happens. I mean, this part should be in the tutorial, not in the homework. But yeah, what can you do? I'm too lazy to edit these videos. Yeah, you can see integer. Oh, it says 1.5 anyway. Fail. Okay, but this was because it was set before the type was changed. But if I try to change it to say 2.3, it will just say nope, and it will convert to 2 anyway. The same here. If I just try, I don't know, negative 0.7 and click apply, it will say nope and go back to 0. So that's why you put 1.0 and 0.0 to say it will be a float, so you can put any float in there in the editor. So that being out of the way, let's change the formula, and this will be really difficult. No, not like this. Like this, and bam, done. So again, it's or I can even, yeah, I think this will make more sense. So first you put the base amount onto the stack. So again, let's just draw it one last time. So first you put the base amount, then you put the unit count, and then you put the coefficient, right? Then you multiply these two. Unit count times, like the star, times coefficient. And then you add these two together with this add. So then that there will be like the total amount. Like this will be the real amount that you want to add, and then you multiply by 1,000,000 just to convert it to the amount that can be set here. So now it should work. So let's see. Scripts compile, and let's try some of the fun that we wanted to. So let's say that this starts at 10 but then grows really slower. Only let's say at 0.5, and this one, let's say that this grows quickly at 2 per unit, but it starts negative at say -10. So this starts by producing anti-creeper, but then turns into producing creeper as soon as you have more than 5 units. I think this will be fun, so let's close. See this already. Wait, it says amount 0. What is going on? I mean, maybe you need an anti-emitter in order to create anti-creeper. Or is it actually creating anti-creeper there? Even if it says amount 0. Okay, well, if you tried to change the unit from creeper to anti-creeper just to make this work, well, that was not part of the homework, so yeah, it doesn't look like it's creating anti-creeper, does it? I don't know, it looks weird. Well, maybe it's... Oh, this is amount 50, that's way too many. Wait, what is going on here? Oh, I switched it around. I said that coefficient is 50 and base amount is 0.5. So it is 0.5 plus 10 times 5. So that's why it's 50.5. Okay, so it just... yeah, let's switch this around. Apply and recompile. Oh, of course! Because I have exactly 5 units. I'm so dumb. Because base amount is -10 and coefficient is 2. So it's -10 plus 2 times 5, which is exactly 0. So let me delete some units here and try it again. Oh, so now it says amount -4 and it is actually creating anti-creeper. Wow, so it's working pretty well. Again, the only thing is maybe... Oh, it just looks the same, but spins, okay, whatever. Yeah, so the amount is -4, and as I build more units, it again, remember, it needs to be built first. It will go up to 2 after these units are built. See, bam. So I think this is actually a pretty neat script that you can put at the start of your base to give you protection early. But once you expand, it will actually start producing creepers, so it's best to destroy it with a nullifier and use the power zone instead. Pretty good. Or you can even make a script to go in the opposite direction by setting the coefficient negative, in which case you can have like a huge emitter in the back that will create tons of creeper. But as you expand your base, it will become weaker and weaker until maybe it will start producing anti-creeper once you build enough units, making it possible to attack that position. That can be cool as well. And all of that with just simple 2 numbers. So that's the great potential of coding in CRPL. So stay tuned for the next episode where we will be exploring even more features and even more commands that you can use to make cool custom units. So thanks for watching and see you next time. Bye!